decided on, because it was cheaper, we had the parts to make it, was we used an Arduino that generates 2 ppm pulse trains. So it basically simulates a transmitter, and that's controlled via serial connection by a laptop using a Python script. So you can, since Python is interpreted, you can also stop at any point to customize the program and restart rather quickly. So that it doesn't use, it uses the same number of parts. The only thing that have been introduced really is this has replaced the temperature control, and now you just have a gamepad and a laptop. So it has the same number of physical parts as the transmitters. It also allows you to use, you can just drive it with 1 controller versus 2. So you don't need 3 drivers to drive 2 robots. You can put all the controls on 1 controller.
For Babs, we initially looked at creating a new claw for Babs because the life form, grabbing life forms and putting them into the isolation pool seems that would require a 3rd degree of freedom, so not only closing and twisting, but as well as kind of an elbow, I guess, or a shoulder. But then after looking at it, we decided that it would make more sense to position the vertical thrusters further forward and backwards and change the controls so that we could just pitch the whole robot like that. And this required several changes. The first was to replace the flotation with something more compact that could be placed more towards the center, which essentially made the robot less stable in the water. So because the center of buoyancy is closer to the center of gravity, it doesn't have such a large tendency to sit upright, which makes it very useful because we can drive upwards at an angle, and we can drive pretty much straight up vertically, which makes the robot much more maneuverable. So we went about that by creating this syntactic foam. This is basically a composite made of small glass microbubbles, which are microscopic glass bubbles that 3M makes, and they're held together with fiberglass resin. So it's extremely lightweight, but still has enough volume to provide buoyancy. That allowed us to, when we made a block of this that sits in the middle of the robot, that allowed us to move the thrusters inward, and which makes the robot much smaller so it can fit in tighter spaces. We also further modified the frame. We moved this thruster back, and we reshaped the bottom of the frame so the robot can actually get in against the bottom corners of a pool or wherever we're driving. And all these changes added up to make a robot that's a lot more maneuverable and also a lot more capable in situations that don't require as much maneuvering, but just tighter control and being able to get in tighter spots.
The pitching ability was particularly useful for the life forms, which have to be put onto a 4-inch pool. And even with the pitching, even if being able to pitch it almost 90 degrees straight up, it's still a task to get them into the pool. So it's a pretty tough mission. The last 3 years, we've been using solar panels to charge batteries constantly, even not during the competition. That's a 40-watt panel right there, and we have another 85-watt outside charging one of the battery packs as we speak. The battery packs are 4 sealed lead acid batteries, 12 volt, wired in series for 48 nominal volt system. The panels and the batteries are also used outside of NERC. One of our uncle, David, had a chance to meet him. He goes to Burning Man every year, and he uses them for different things like showering and things like that. So they actually get quite a bit of use outside of NERC.
Another thing about the green charging is we don't actually have we don't have any chargers set up for charging these batteries beyond the solar panel and the solar charger. So even when we're prototyping robots, they're always, for their entire lifespan, these two robots have always been charged using solar power.
Okay, so we had to go through and decide on how to actually approach the mission this year because we have 2 robots. So that makes it easier to accomplish all the mission tasks. So we decided to divide the workload, but there's a few things we had to think about because Not Bob doesn't have the same capabilities as Babs. Not Bob's clog can't twist. So there's things like the data logger that Babs has to do, which is a winch. So she actually has to grab onto it and rotate. Babs is also quicker and has a better clasper for grabbing the life form. So we figured she'd be easier to deal with trying to chase those down. And also you can read the depth on here and you calibrate that before you head out. So that feature's not working on Not Bob right now, but Babs is. Not Bob, we're going to send him out to do the thermometer because he can easily drop it off and take it back. And release the fuel rod and do things like pushing the UAV. He has a lot of power, whereas Babs, it's more difficult for Babs to push things. And do the sensor array is also an easy task for Not Bob to maneuver around and push the PVC over.
And it turns out that the tasks that we've divided among the robots has it such that Not Bob is doing a lot of the tasks near the floor of the pool, and Babs is doing a lot of things up higher with the life forms putting them in the pool. So it turns out that the tether management is going to be a lot easier than we expected, even with the hole.